Proving congruence, angle side angle. ASA theorem. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. So here we have two angles and the included side, two angles and the included side. Here's the theorem in action. Given that AB equals PR, angle B is congruent to angle R and angle A is congruent to angle P, prove that the two triangles are congruent. Well, we start with the given statements. Then we see that AB is congruent to PR because that's the definition of congruent segments. Therefore, the triangles are congruent due to the angle side angle theorem. Here's a proof of the angle side angle theorem. Given that angle A and angle P are congruent, and angle B and angle R are congruent, and this line segment AB is congruent to this line segment PR, prove that the triangles are congruent. So we start with our given information. We see that the triangles are similar because of the AA similarity theorem. They have two pairs of congruent angles. This is also given that these line segments are congruent, therefore they are equal because that's the definition of congruent segments. It's an arithmetic fact that if you have one over the other, it equals 1. And the definition of similar triangles states AC over PQ equals BC over RQ equals 1 because this is the definition of the ratios of proportions in similar triangles. It's an arithmetic fact that you can then rearrange it to say AC equals PQ, BC equals RQ, because that's an arithmetic fact. Then we see that AC is congruent to PQ, BC is congruent to RQ. That's the definition of congruent segments. Therefore, by the side-side-side triangle congruence, the triangles are congruent. Here is the two-column proof puzzle. Given that FG is parallel to KL and JK is parallel to GH and line segment FJ is congruent to line segment HL, prove that the two triangles are congruent. So we start with our given information, and then we see that angle F here is congruent to angle L, and angle GHJ is congruent to angle KJH because alternate interior angles are congruent. All right. The other piece of given information was line segment FJ is congruent to line segment HL. Therefore, FH is congruent to JL because that is the common segment theorem. Oh, I forgot to put given. And then finally, the two triangles are congruent because of the angle side angle triangle congruence.